Hi, this is Lab5, Choose Your Own Adventure. For this lab, we were given the freedom to kind of explore whatever we wanted to that was of interest to us. So, the general objective for this lab, as a whole, is to kind of showcase our development of knowledge and skills during this course. And the more specific objective for this experiment is to see how much windy conditions affect the flight pattern of a basketball. And I chose this just because I like playing games outside, and as anybody can tell you, wind can have a great impact on the playing of games. And I chose a basketball because it was the easiest to find the center of mass for. And we'll find after a few slides that wind definitely does have a great impact on the flight pattern. So the relevant physics will primarily be Newton's second law. It's the velocity equation, the position equation, and down here the last two that may not be as familiar is the x and y component of the velocity updates. And this was just important for this specific lab. Is right here in the first number of the y equation is just the gravity influence, and then the initial velocity and the initial position. Down here is just the initial velocity of the x component, because gravity doesn't have a y or x component. So that was just useful for this specific experiment. So I'm going to show you the video just so we know what exactly motion we're dealing with here. It's just basketball being thrown in arc motion, and its position versus time is being plotted and charted. And I catch it over there, and then so the here's the V-idle model that I made to predict the same motion. And there are a couple flaws with it that I'll discuss in the error report. And basically it just has the same motion. And the graph actually, I put the while loop to be 2 seconds rather than 3.7 like the actual video. And that's because of the wind made the flight not as long as it theoretically would be. So I just made that so that you could actually see it. But it's actually cut to about 1.5 seconds really. But just because the wind pushed it, the ball didn't actually go as far as it should have. So that was a cool thing to note. And so I'll go back to the PowerPoint so we can discuss the coding. Here's the initializations used. It was placed on the origin, and the initial velocity was just found by using change in position over change in time in tracker. And then the angle between the x-axis and the initial velocity of the motion was important for the coding in order to find the x and y components of the velocity. And so just use basic trigonometry for this. And here's a coding of the physics. It was while loop under 2, which was as I noted, one of the error reports, but it was an expected one. That's why we were doing the experiment. And it's really just the velocity and new position updates, and that gave us our model. So follow up. Obviously wind did affect the motion. There's interesting correlation numbers. So I told you that the while loop was for 2 seconds, whereas the real flight pattern was around 1.5 seconds. And actually that correlated with the distance difference as well. It was about a 50% difference in distance traveled. So I don't think that's just a coincidence, but rather the wind actually had a correlating impact on the basketball. So could we have made a model for this predicting the non-ideal motion? So yeah, I think that we could have made a model incorporating the wind effect, although that's not quite the point of this specific experiment, but it'd be a cool one to do maybe one day. And could we have used other things we learned during this class? The primary thing that comes to mind, of course, is the energy principle, and I don't really go into that just because I'm personally more interested in the motion of the actual ball. But energy principle is also interesting, and I'll give a few comments about that. Obviously, since if you consider the ball and the earth as the system, then change in energy will be 0, because everything, kinetic energy is changes 0, and change in potential gravity energy is 0. And so that's a bounded motion, and yeah, that'd be cool to look into for a different experiment maybe. So in conclusion, air resistance definitely did affect the motion of the ball greatly. As I said, the ball would have gone about 50% further and would have been in the air for about 50% longer. So that's a pretty significant impact. Although it was being thrown straight in the wind, which was the weather report said it was around 15 miles per hour. But you know, so also we can conclude from this experiment that after taking Physics 1, we're now equipped to explore and analyze basic physics that we see in everyday life. So that's something pretty cool that we can take from this course. Thank you.